In this video, we are going to learn how to solve exam-style questions in trigonometry. Let's read the question. G theta equals 4 cos 2 theta plus 2 sin 2 theta. So let's highlight the key expression here. G theta equals 4 cos 2 theta plus 2 sin 2 theta. Given also that G theta equals to r cos 2 theta minus alpha, where r is positive and alpha is between 0 and 90 degrees. We need to find, in part A, the exact value of r and the value of alpha to 2 decimal places. Let's see how to solve it. We'll write g theta function. G theta function is equal to 4 cos 2 theta plus 2 sin 2 theta. And also I can rewrite g theta by using the other version, which is r cos 2 theta minus alpha. Now we can expand the second function. Cos 2 theta minus alpha can be expanded in this form: cos 2 theta cos alpha plus sin 2 theta sin alpha. Now our next step would be expand in this bracket, so which is gonna be r cos alpha cos 2 theta. I'm just exchanging these two. It doesn't matter. A times b is same as b times a, plus r sin alpha sin 2 theta. Now this is my equation 1. My second equation would be 4 cos 2 theta plus 2 sin 2 theta. I just wrote this one right underneath because my next step would be comparing the two expressions. So if you look carefully, the same g theta function is expressed in two different ways. The first part of that, cos 2 theta, is same, therefore 4 should be equal to r cos alpha. Similarly, sin 2 theta is same, so 2 should be equal to r sin alpha. So we can rewrite this like this: 4 equals r cos alpha, which is equation 3, and 2 equals r sin alpha, which is equation 4. Now what we can do to find the value of r and alpha? So we can square equation 3 and add with square of equation 4. So once you square the equation 3, you will get 16, and once you square the equation 4, you get 4, which is equal to square of the equation 3 will be r squared cos squared alpha, and the other part will be r squared sin squared alpha. Now 16 plus 4 will be 20, so r squared can be factorized. It will be cos squared alpha plus sin squared alpha. So r squared is gonna be, this is 1, r squared times 1 equals 20. So we can rewrite r squared equals 20. R is equal to square root of 20. Since r is a positive value, we are not going to consider the negative version of it. So if you want to simplify it, you can simplify it a bit further. So it will be 4 times 5, which is going to be 2 root 5. So that's the value of r. So now how to find the value of alpha? We can copy down the same equation. Let me copy down this equation to the other side. Okay, now what we can do here, is we can divide equation 4 by equation 3. If we divide these two equations, we can see that r is getting cancelled. R sine alpha, you divide it by r cos alpha. The right hand side of the fourth equation divided by the right hand side of the third equation. So r sine alpha divided by r cos alpha. R is getting cancelled. Sine alpha divided by cos alpha will be tan alpha. So this will be half. So in order to find the value of alpha, all what you need to do is find arc tan, which is same as tan inverse. So take out the calculator. Make sure that the mode of the calculator is in degrees. So tan inverse half, which is 0.5, is going to be 26.56. My value of alpha is 26.565. So I have to give the answer to 2 decimal places. So it is 26.57 degrees. Okay, now let's see how to solve part B. Hence solve that theta from minus 90 degrees to plus 90 degrees, the equation 4 cos 2 theta plus 2 sin 2 theta equals 1. So in part A, we proved that 4 cos 2 theta plus 2 sin 2 theta, which is the left hand side of this equation, can be written down in this format. So moving forward, we'll be using the new version, which is r cos 2 theta minus alpha, for our convenience in simplification. So we can rewrite the given equation, which is 4 cos 2 theta plus 2 sin 2 theta equals to 1 by replacing our simplified version, which is 2 root 5 cos 2 theta minus 26.57 degrees. Now, before we solve these type of trigonometric equations, what we need to do is we need to make sure that we are having a right range for theta. So our theta is going from minus 90 degrees to plus 90 degrees. Now let's rearrange it so that we can see the range of 2 theta minus 26.57. So if theta is moving from minus 90 to 90, then 2 theta, which is double of that, moving from minus 180 to plus 180. Then if I take away 26.57 from both sides, theta will be 180 minus 26.57. That will be 153.43, and minus 180 minus 26.57 will be minus 206.57. Now what we can do is we can start solving this equation. So we can rewrite by subtracting cos 2 theta minus 26.57, send 2 root 5 to the other side, so it goes as a division, it will be 2 root 5. Now in order to find the range, all the possible values of 2 theta minus 26.57, what we could do is we can find cos r cos 1 over 2 root 5. So you can type it in the calculator. So it will be cos inverse 1 over 2 root 5 which is 77.079. It goes on. Now if you look at this cost value is positive. So we need to find all the possible angles that gives you the same positive value for this cos. So if you draw the cos diagram, according to the cos diagram, cos is positive in the first quadrant and the fourth quadrant. So let's scan all the possible angles for 2 theta minus 26.57, ranging from minus 206 to plus 153, where you get a positive answer for 1 over 2 root 5. So if you look carefully, one of the angle is 77.079. So we need to find other possible angles. So if you go from all the way from to 153, will be in the second quadrant. Therefore, there's no other angle that gives you positive angle. So we need to go for the other angle, which is the negative version of it, minus 206. Minus 206 will be all the way from here to there. So we will be getting another angle, which is 77.079. It's like the reflection of the same angle that we've just found. So there is no other angle that gives you positive value for cos 2 theta minus 26.57 other than 77.079 and minus 77.079. Why do we need to give the answer in negative? Because the maximum positive angle that you can written down for 2 theta minus 26.57 is plus 153. If you want to represent this angle, which is in the fourth quadrant, you need to give its negative version of it. So which is going to be minus 77. Okay. So we found all the possible angles that gives you positive value for cos 2 theta minus 26.57. Now it's time to subject or solve for theta. So what we can do is we can rewrite 26.57 need to be added for both these values. So first let's add for 77.079, 26.57. When you add it, it will be 103.649. Goes on. And for the other angle, let's add 26.57. That would be minus 77.079 plus 26.57. That will be minus 50.509. Now we need to find the range of theta. So we need to half these angles. So half of minus 50.509 will be minus 25.25, and half of 103.649 will be 51.82. So we managed to find the answers for theta, but we need to give the answer into 1 decimal places. So 1 decimal place, so we'll need to round it. So 51.8 or minus 25.3. Now let's see how to solve part C. Given that k is a constant and the equation g theta equals k has no solution. There are no solutions for this equation. State the range of possible values of k. So what is our g theta function? Our g theta function is 2 root 5 cos 2 theta minus 26.57. Our g theta function is 2 theta minus 26.57. Now we all know that cos x is always between minus 1 and plus 1. So there is no solution for cos outside this range. Therefore, we can confirm that even cos 2 theta minus 26.57 lies in between minus 1 and plus 1. So if you need to find any solution for this function, that should be always between minus 1 and 1. Now, if it is for g theta function, which is 2 root 5 times cos 2 theta minus 26.57, so we would write times it by 2 root 5 cos 2 theta minus 26.57 between 2 root 5 and minus 2 root 5. So all the possible values for this function lies in between these two values. So if the function g theta, which is equal to k, has no solution, that means this g theta should be, which is equal to k, this should be either more than 2 root 5 or the same k value should be less than minus 2 root 5. So the solutions for part C would be k is less than 2 root 5 or minus 2 root 5, or k is more than plus 2 root 5.